Yes, you're able to see it. Okay, wonderful. So we can begin. So the very first topic that was actually eliminated from version 2.2 is this topic. It goes by the title Basic Enterprise Network Architecture. I don't know why they removed it, but I still think it's important that we begin here. And that's why I'm going to take you through it. So the Basic Enterprise Network Architecture. Now, even before we go further, let me just move this. Okay. Now, even before we go further, I want us to decipher this name because we are going to be seeing it one too many times. An enterprise. What's an enterprise? What's an enterprise? Any volunteer? Anyone who loved business? They can tell us what an enterprise is. You can just unmute your mic and go ahead. Yes, Kilonzo. Thank you for raising your hand. Nick, are you sure we can hear you now, really? I think your mic has an issue. Okay, someone else raised their hand. Just go ahead. I cannot be able to see who you are. Just unmute.
An enterprise is a company.
Exactly.
Can you hear me?
Yes, 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 we can hear you. Go ahead again. An enterprise?
Oh. Okay, it's a business or a company.
Exactly. So an enterprise is simply a business. A business? Sana sana formal business. And a formal business, sana sana, is also referred to as a registered company. An enterprise. So we'll be talking about the enterprise network because when you do this level of routing and switching, you should be able to manage and understand how to design, build, implement, and also maintain a company's network. One of the company that I'll be referring to most of the time is Multimedia University of Kenya. It's also an enterprise. And so most of the time, I'll be giving examples in regard to this enterprise. So this is also commonly referred to as a campus network. Campus network. An enterprise network. So in this particular chapter, we just want to understand how does it look like? The network for an enterprise, how does it look like? The architecture. So that is what we want to understand here. Okay. So most of the time I'll be reading out for you the foreword. So enterprise business requirements highlight a need for networks that are capable of adapting to ever-changing business demands in terms of the enterprise business growth and evolving services. It is imperative, therefore, to understand the principles of what constitutes an enterprise network and how it is formed and adapted to support real-world business demands. By the end of this chapter, you should be able to, number one, Kenneth, you can just unmute your mic and read for us these objectives.
Okay, upon completion of this section, trainees will be able to explain what constitutes an enterprise network, describe the common enterprise network architecture types, describe some of the solutions commonly implemented within an enterprise network to support business operations.
Yes, wonderful. Okay. Now, let's start here. Let's start here. What is a computer network? What is a computer network? A volunteer? What is a computer network? How can we define a computer network? Anyone? I think two participants have raised their hand, so I cannot see who specifically. The first one to go, just unmute your mic and go ahead.
Interconnection of many computers.
Interconnection?
Of many computers.
Interconnection of computers. Interconnection of computers. Thank you very much. That is correct. And most of the time they say for the purpose of sharing what? Information. And or resources. And therefore, sometimes it's important to know when you talk of information, what are some of the information that can be shared between computers? Anyone? What are some of the information that can be shared between computers? Okay, so you can have things like files, emails, what else? Of course, files carries many things like videos. Yes, Gadudi? Go ahead.
You've lightened what I wanted to say.
Okay, what you wanted to say. Okay, what are some of the resources that we might need to share within a network? Yes? Someone?
Printer.
Yes. Can be hardware, things like printers. We can also share the processing power. Gibran?
I was exactly wanted to say that. The printers, the
hardware. We can also share software, right? So through the network, we can share so many other things. And in fact, this is what supports one of the trending topics in ICT right now, which is called cloud computing. And through cloud computing, of course, now we have other. Okay. Are you still able to hear me?
Hello. Hello.
Are you still able to hear me? Gibran?
Yeah.
Yes, I can hear you.
Okay. I think kuna mtu anaitwa Hono 7 or someone. Just mute your mic. Okay. So through technologies such as cloud computing, that's why we need data centers and so on and so forth. Now, after understanding what a network is, you need to understand now, what is the internet? What is the internet? Anyone who can introduce to us what the internet is?
It is the global interconnection of computers, basically the one.
Global
interconnection of computers.
Of actually what we call computer networks. Global interconnection of computer
networks.
Global interconnection of computer networks. Now, generally, computer networks, we have different, let's say, categories of computer networks in regard to size, in regard to the size of the network. So one of the categories is called the LAN. In full, it's a local area network. So this is a term you're going to be seeing so many times. So this one generally occupies or covers a small to medium geographical size or area. Then the next one, someone?
Wide area network.
Exactly. So we have the WAN or wide area network. On the other hand, wide area network covers a large geographical area. e.g. So here we didn't say e.g. Here e.g. a building, a campus, etc. Then for once, we are talking of a country, networks that interconnect countries, continents, and most of the time, in fact, the one is interchangeably referred to as the internet. Now, in between the LAN and the WAN, we have another computer network in regard to size. What do we call it? We have another category.
Man.
We have the
Man.
yes, man. So man is metropolitan area network. Now the man, let's say a network that spans a county. Yes, Joshua, you have a question or suggestion?
No.
Okay. Now recently, I also learned of another network type which is gaining traction, and it's called the BAN. The BAN is the body area network. So if you watch some movies and we have a guy in the hospital and there are all these cables that have been connected, sensors that have been connected to their body, and they are sending some info, like temperature, heart rate, blah, blah, blah. So that particular network is called the BAN, or the body area network. Okay, now, once you've understood this, now the other thing you need to understand is that networks generally, enterprise network exist in many well-known industries. So in financial institutions like banks, in education institutions like Multimedia University, in government, many enterprises. And now, each of these networks, you can think of it as a LAN, as a local area network. And now, when we interconnect them, then we form that global interconnection of LANs, and it makes the WAN, which is also referred to as the internet. So in particular, this course is supposed to make you a junior network engineer. I know some of you already passed that, but it's supposed to help you to understand the concepts of running a network for a particular enterprise. As you can see, networks range from offices to large industrial platforms. Okay, and computer networks are not the only networks. In the world, we already have many other types of networks. So we don't just have networks between computers. What are some of the other networks in the real world that you know? The existing networks. Like I'm sure you've heard of red networks. Yes, go ahead. Just unmute your mic and tell us.
Water networks.
Exactly. How the water network. Another one?
Sewage networks.
Exactly. Sewerage networks. Another one?
Power networks.
Electricity network. So hizi zote interconnection. And one of the most important one, people networks. Unajua nani? Bora utafanya tu certification mingi ukiziekanga tu kwa nini. Lazima ujue watu, my friend. And that's where you'll need to make friends. Here we have very senior people here. So you need to make friends and know people. That is what we call the people's network. So hizi zote ni networks. So computer networks, they use different rules, but the interconnection is almost similar. Almost similar to this. And that's why hata kwa road tuko na different roads depending on the area they cover. We have county roads, we have national roads na vitu kama hiyo. Just like in computers. Okay. So let's move on. Now, I told you in the previous slide that you're going to learn how to manage an enterprise network. And in the previous page, that enterprise network was just in a single building or within a single university like Multimedia University. But generally, the truth is, yes, you'll have Multimedia University here, but Multimedia University will have a town campus in Nairobi City Center. It will have another town campus in Nakuru, another campus in let's say Mombasa, and it will also have what we call online learning students. Now, all these people need to use your enterprise network. Need to use your enterprise network. And your enterprise network is also commonly referred to as the IP network, because the internet protocol is what runs your local area network. So when we have these branches, we need to connect them to the headquarters and interconnect them together using or over the public network. And we are going to see how. So we are going to learn several technologies that can enable us to do that. So generally, these other branches are what we refer to as the remote. Sorry. Just a moment, I want to move this. Okay. So these are what we refer to as the remote networks. Remote networks. So branch A, branch B, on-site employees, branch B, all those are remote networks. And we want to interconnect all of them with each other and particularly with to the headquarters. Okay, so it is because of this particular feature that today we have what we call anywhere, anytime banking. One of the biggest advantages of computer networks. So to the younger people here, they might not know that a few years ago, if you created an account at Equity Rongai branch, then you could only transact at Equity Rongai branch. You could not withdraw money from Nairobi CBD branch, Moi Avenue branch. No. But today, because of computer networks, today we even have agents. So we have the headquarters and we have the agent. You can withdraw from an agent. And when you withdraw from an agent, that data will be relayed over the IP network all the way to the headquarters. You can withdraw from any of the other branch, and that data will simply be sent within seconds and updated to their main databases. So that's one of the main advantages of computer networks. Now, this is now what we call the architecture. This is what we call the architecture, and it is important that you understand it because we'll be mentioning some of these things more and more going forward. So we have what we call the flat we have what we call the flat, I need to flatten in, why am I forgetting? I'm failing to remember that, but
Layer.
just come. Yeah, let me just call it the flat layer architecture. And we have, I think, the hierarchical layered. Exactly, that's the word. Hierarchical layered architecture. Okay, so we have these two. So layered architecture and hierarchical layered architecture. Now, generally, small enterprises will use the flat layer architecture. On the other hand, large enterprises will use the hierarchical layered architecture. Now, we have several requirements that demand that large enterprises use the hierarchical layered architecture. One of them being what we call scalability. Scalability is ability to expand. So, for example, in my undergraduate, I did my undergraduate at MMU. So we joined MMU in 2010. That is when it was just, we were the first people actually, after it has just been turned from, I think, a college to a university college. So the population was about, I think, 2,000, the student population. To date, the population is about 6,000. So you see, the network that supported those 2,000 students cannot be the same network that is supporting 6,000 students. It needs to also grow with the demand. So the ability of a network to grow is what we call scalability. So flat layered architecture does not scale. It does not scale. It cannot be able to expand to meet demand. To expand to meet demand. The other one is also availability. So large enterprises really depend on their network for telephone calls, for accessing the website, for accessing so many other things, and therefore availability is how can I define it? Can someone help me to define availability? What is availability in simple terms? Anyone? Anyone?
Can we say?
Can
we say it's the uptime?
Exactly, that's the word. So let me say percentage uptime. So generally, your network is supposed to be up like 99% of the time. So most of the time, with layered architecture, we are able to ensure that it's up because we offer what we call redundancy. So I'm going to show you what redundancy is in a short while. The other clear demand for large enterprises is what we call security, especially data security. You've had something like data is the new oil. So enterprises treat their data very confidentially, in high regard, because if a competitor steals, for example, a business secret and they go ahead and implement that particular strategy before them, then they're going to lose a lot. So again, any large enterprise will always want what we call data security. So your network has to meet the security demands. And for those reasons, any large enterprise will always use what we call a hierarchical layered architecture. Okay. So let me show you what we call the flat. This is just an example. So you can think of this as a flat layered architecture. So I don't know. Let me just begin with this other one first. Let me clear that. Let me begin with this side. So generally, this is a network for a large enterprise, and it uses the hierarchical layered. So in terms of hierarchy, we are talking of, we have several layers. One of them is called the access layer. The other one is called the aggregation layer. The other one is called the core layer. So generally, the core layer is what connects you to your wide area network. Generally, at the core layer, we have devices that are called routers. We are going to look at them. So anytime you see this icon with an R, just know that this is a router. This is a router. So the router will connect you to your ISP. An ISP is an internet service provider. Internet service provider. E.g., Safaricom, they're internet service providers. When we come to universities and other institutions, especially of higher learning, we have what we call the KENNET, or Kenya Education Network. They're the ones that are mandated by the government to provide internet to educational institutions. So at the core layer, you have a router that is now connecting you to your internet service provider. Okay, then after that, we have the lower below it called the aggregation layer. At the aggregation layer, most of the time we use a switch. Now, these are switches. Similarly, these are also switches here. Now, the difference between this switch and this switch is that this switch is what we call a layer 3 switch. So you're going to understand what a layer 3 switch is in coming topics. Then this one here is called a layer 2 switch, a layer 2 switch. So we're also going to understand it. Now, let me skip the aggregation first and come to the access layer. Now, the access layer is used to connect to your end devices. These end devices are also called access devices, or they're also referred to as hosts. So a host can be a PC, it can be a laptop, it can be a tablet, it can be an IP phone. Most enterprises are using IP phones. It can be a server. It can be your email server. And it can also be your wireless access point. It can be your wireless access point. And this wireless access point can now connect many other access devices to your network. So generally, what happens here is this. So the reason as to why these switches are called access switches is because they're the ones that interconnect. They're the ones that interconnect to these end devices. That's why they're called access, the access layer. They are the switches that are at the very end, give network connection to that particular user. So for example, in a university setup, we have computer labs. So this particular switch that interconnects devices within that computer lab is called an access switch. Now, after the access switch, we have the, let me just clear it. After the access switch, we have the aggregation switches at the aggregation layer. Generally, as you can see here, all data that is coming from all the end devices in your network actually aggregate. They meet at the access switches before they now are taken to the router and they are taken out to the internet or the wide area network by your ISP. So that's why we call it the aggregation layer. Now, as you can see, especially at the aggregation layer, we always have what we call redundancy to ensure availability. Redundancy is providing more than one link between devices. As you can see, even here at the access layer, we have two links. So one link is going to this layer 3 switch, the other one is going there. So that in case one link goes down, then these people are not going to be isolated. They're not going to miss network connection. So that's why we have that redundancy. And this is one of the requirements for a large enterprise network. So that's the aggregation layer. And lastly, of course, as I've said, at the core layer, we'll have the router. The router will connect you to the WAN. Now, because of security issues, most of the time we have two boundaries. This boundary here, what I've just highlighted there is what we call your internal private network. Internal private network. Now, sometimes you might also have another boundary here, and this particular boundary here is these are devices who you want to be accessed both from your internal network and from the public network. So the internet is what we call the public network. So easy servers hapa, servers kama web server, email server. So kama email MMU, I can be able to access it from my home office here. So these servers that you want to be able to be accessed from within your network and also from the public network, we usually put them in a place we call the demilitarized zone, DMZ. And we can also refer to that as a server farm. So you'll hear of what we call a DMZ, DMZ, or demilitarized zone, militarized zone. Demilitarized zone. So this particular layer here is referred to as either the DMZ or the server farm, and the purpose is to ensure that hawa watu wenye wana access from nje, they'll not have to go into our network. Unaona, kama tungekuwa tumeiweka huku ndani, lazima waingie kwa network yetu, wakuje kwa router, wakuje hapo, and then waingie kwa hii server. So wataingia kwa network yetu, but because hatutaki, tunaiweka kwa hii area inaitwa DMZ, so that wakikuja kwa hii router haitawaingisha kwa network yetu, inawaleta hapo kwa demilitarized zone. So I hope that is clear. So that's the other security feature that is actually implemented in most large enterprise networks. Then on the left we have here we have an example of a flat layered architecture. So let me just mention something before I move on. So you see here, a switch will have we have what we call ports, and those ports we're going to be calling them interfaces in this training. So a switch will have many ports. We have 12 port switches, we have 24 port switches, we also have 48 port switches. So if MMU is commissioning a new computer lab, maybe an AI lab or an IoT lab, they'll simply connect a switch to the aggregation, to a port on the aggregation layer switch, like that. If they're opening another lab again, they can do that. Again, this switch might also have some ports, and we can also connect it to another switch, which can provide network connectivity to another particular lab. So this is what we call scalability. With a layered architecture, you can be able to add other switches on the access layer as per the demand of your business growth. But when it comes to a flat layer architecture, most of the time, for example, kama ka cyber cafe, unapatanga tu iko tu na switch moja ambaye imeconnect to your termination point ya ISP. Like right now, we have a concept called FTTH. Sijui kama mmesikia, that's one of the fiber to the home. So most of the people, just like they have electricity and water, most of the people are having fiber being brought into their homes. And Safaricom are very aggressive in this particular project. Also JTL, we also have fiber when you want to advertise all the time. So these guys are bringing fiber into our homes. So when that fiber is terminated there, they leave you with an access point. So that network cannot be able to grow so much because it's a flat layer architecture. So hata hii hapa kando, it's not a very good example of a flat layer architecture because we still have a router and we also have an aggregation layer here and an access layer here. But think of a network kama ya cyber cafe. It cannot be able to expand so much because it's not layered. So I hope you've gotten that idea. But most importantly, in this particular slide, please remember these three layers. The core layer that interconnects you to your ISP, the aggregation layer, where all the traffic congregates from the access layer. Then the access layer that provides connectivity to the end devices. So these are the end devices. So please remember that. Also remember that this is a router, these are routers. Remember that this is a layer 3 switch, this is a layer 2 switch. And also remember the DMZ, Okay. Okay, so generally for these questions at the end of the chapter, I'll be calling out on specific people to read the question and help us answer it. But for this particular one, I want you to read it and try and answer it by yourself. If you can't answer it, we have the answer just at the bottom there. You can have a look at it. In the meantime, I'll be opening the next chapter. Thank you. Any question, by the way? Any question so far in this topic? Okay, good. Then